Hello and welcome back to another video on this channel. It's me, David AKW, and today we're going to be solving some physics problem from the homework in which was due, is due tomorrow, Friday, 9/20th. September 20th, 2024. Anyways, I'm sorry if the photos are really blurry. I was gonna try and see if there was an actual PDF I could download, but there wasn't, so I had to individually take a photo of every single one of these questions. Anyways, let's start off with the first one. This is a force of tension problem, so we should begin by drawing our free body diagram. Here we have our 10 kilogram object, right? This is going to be the same as having T of a y and T of a x on the side, right? So we're going to have let me make this longer. We're gonna have T of a of x and T of a of y here, and then T of b is just in the x direction, so I'm just gonna say T of b, and can't forget f of g. So our f or g is mass times gravity. In this case, we're just going to round it to 10. So our f of g is going to be 10 times 10, 100 newtons. Now, how do we solve the rest? Okay. We know that, let me see, what is the question asking? What is the approximate tension in newtons in cable A? Okay. We know that F net of y is going to equal to TA of y minus 100 newtons, and it's going to be 10 times 0 because F net is mass times acceleration, I think. So T of y minus 100 newtons, this is just going to end up being 100 newtons is equal to TA of y, because this part right here, it's going to be 0, and we just move this 100 to the other side over there. So yeah, knowing that, we're gonna do this little triangle here. What's the degree? 60 degrees. And on the side here we have 100 newtons, because that was our T A of y, and we need to figure out what is T of a, right? So we're gonna do sine of 60 is equal to 100 newtons over T of a, right? Which means that T of a multiply on both sides and then divide sine of 60. T of a is going to equal to 100 over sine of 60, and sine of 60 is also square root of 3 over 2. Let me actually zoom in so I can write this out right here. Sine of 60 is equal to square root of 3 over 2 right here, right? So we're going to use this to, oh man, I'm not good at organizing stuff. I hope you guys don't mind that. Anyways, TA is equal to 100 divided by square root of 3 over 2. Do this, forgot what this is called, multiply by the reciprocal, and we get 200 over square root of 3 newtons. This should be your answer. Don't know why that happened, but that should be your answer right there. Anyways, moving on, we have question number 2. If the position function of a particle is x of t equals t cubed over 3 minus 3 t squared plus 4, find the times where the acceleration of the particle is 0. So we're going to take the derivative of this. B of t is equal to 3t squared over 3 minus 6 of t, not 6 of t, minus 6t, which means a of t is going to equal 2t minus 6. And to find out when acceleration is 0, we'll just make a of t 0 is equal to 2t minus 6. We have 6 right here is equal to 2t divided by 2. That means acceleration will be 0 at 3 seconds. There you go. That one's really easy. Number 3. Oh, sorry. First I have to say this. This isn't made so that you can just steal the answers. Okay? It's a guide for you to learn along. I'm putting this out there in case you need help or assistance with these problems, and if anybody else just happens to pass by that isn't from my school, you can watch this to maybe, you know, enhance your physics learning. Anyways, a 20 Newton object is pulled along a horizontal surface at a constant velocity by 3.0 Newton's force. What is the coefficient of friction? Basically, what this is saying is that the weight, force away, is going to be 20 Newtons, which means that the object itself is 2 kilograms. And that means that Fn is going to be 20 Newtons as well, and is being pulled along by a constant velocity of 3.0. Okay, so we're going to do 3 Newtons of force, and we have FKFF for force of kinetic friction. Yeah, kinetic friction force. Okay, there we go. Anyways, sorry. Whoa. We know that F net of x is going to equal to 3 minus FKF, and we know that F net is equal to mass times acceleration, so it's 2 times a is equal to 3 minus, and I'm going to write out Fk of F into its separate units. We have mu k times mass times 10, well actually times Fn, which in this case is mass times 10, so it's going to be uk times 20, right? How do we solve for acceleration? Oh, let me remember. Let me look at my packet again. I kind of forgot. Oh, it's 0 because it's being pulled around at a constant velocity, and when you have a constant velocity, the acceleration is going to be 0. So 0 is equal to 3 minus uk 20. So let me put this up here. Negative 3 is equal to negative mu k. Don't know what I said. U before 20. Divided both by 20, and we can just rewrite this as both positive because both are negative, which means it would be the same as positive. So mu of k is equal to 3 over 20. This is our coefficients of friction, and if you put that into a calculator, you should get around 0.15. That's your answer right there. Move on. Let's go to the next one. We have 4. A 5 kilogram object is sliding across the surface of a table and slows down due to frictional force. If the object's initial speed is 3 and it comes to stop in 1.6 seconds, what is the coefficient of friction between the object and the surface of the table? Okay, let's draw our free body diagram first. Alright, 5 kg, F of g is going to equal to 50 newtons, and pretty sure for this one F of n is also equal to 50 newtons, and we have F K of F right here, right? So let's see. We have our initial velocity, which is going to be 3, right? And it comes to stop, so BF is going to be 0, and our change in time is going to be 1.6, and we know that F net of x is equal to Fk of F, which means what was the mass? It was 5, right? Yeah, 5 times A is equal to mu k. Sleep on, get out of here. Mu k times Fn, which is just 50, right? But we don't have A. We need to solve for A first. So we're going to use this equation right here where it's Vf is equal to Vi plus A times change in time. So Vf is going to be 0, 3 plus A change in time. Sorry, not change in time. We know what change in time is. 1.6. So negative 3 is going to equal to A times 1.6. Divide that by 1.6. 1.6. We're going to get A is equal to, let me just look at what I wrote down here because I don't want to type this. I'll have negative 1.870. 6.5. There we go. And now that we know this, this is gonna be negative because it's playing on the negative side. Don't try and fix me. I know what I wrote. Anyways, so 5 times negative 1.875 is equal to negative mu k times 50. I'm just gonna already divide by 50 because I'm trying to do this really fastly. So it's gonna end up being uk, and then again, because it's negative right here, actually let me just use the laser pool, because it's negative right there and also negative right there, it's just gonna end up being positive too. So uk, well, we can just divide by negative 50. There we go. uk is gonna be, put this into a calculator, you're gonna get around, let me change this sign so that it's actually much more accurate, around 0.1875. That's your UK. Moving on. Question number 5. What tension would accelerate a 5.0 kilogram object suspended on a string upwards at 6.2 meters per second squared? Okay. Once again, we start off with our free body diagram. 5 kg. Yes, that's a 5. Horrible 5. Or I don't really have that much space anymore, but our f of g is going to be 50 newtons, and that means, and since we're being pulled by force of tension, that's going to be that. We know that acceleration is 6.2, so f net of y is equal to f of t minus 50, and so 5 times 6.2, put that in your calculator, it's going to be 31, is equal to f of t minus 50. Add 50 to the other side, f of t is just equal to 81 newtons. There we go. Moving on to the next page, we actually have part B over here to that same problem, except it's going to be if it's going downwards at a speed of 6.2. So instead we would do 5 times negative 6.2 is equal to f of t minus 50, and this would just get us negative 31 is equal to f of t minus 50. Add 50 to the other side, you could just do 50 minus 31, which would get you, am I doing this correctly? I hope I am. 13, right? Yeah, 13. 13. Am I doing this correctly? No, I'm not. Oh, that's not a 7, that's 31. My bad, guys, my bad. Sometimes I end up, what the hell? What's going on here? Why wouldn't that go away? Okay. Sometimes I just end up, misinterpreting my own handwriting. Anyways, 19. That means f of t is equal to 19 newtons. Boom. And this makes sense because since f of t is less than f of g, it's going to go downwards. Anyways, okay, moving on to the next one. 15 kilogram block on horizontal surface has a 100 Newton force acting on it as what does that say? I don't know. Anyways, what this is saying is that the force of 100 is pulling on it up, right? But the mass is 15.0 kg. So, and we want to find the normal force. So we're gonna do 15 kg. That means f of g is equal to 150 newtons, and f of n has to be, sorry, f right here is equal to 100. I think you don't really see that well there, because, okay, let me just write it down here. F has to equal to 100. That means f of n has to be what's left over to make that. You don't really gotta do this. You can do mental math really easily, but just f of n plus 100 minus 150, 0, and well, yeah, that's gonna equal 0 because it's not moving. So 150 is equal to fn plus 100. Subtract 100 from both sides. That means fn is equal to 50 newtons. Although for this problem on the answer key, it will be 47 newtons, and that's because instead of using g equals 10, right, it's going to use g equals 9.8. So, sorry, meters per second squared. If you go back and do it, this would be 15 times 9.8, which is going to be 147. And then you just plug 147 in for there, and then 147 minus 100 is going to be 47 newtons. So there's your answer. Anyways, this one's really easily, because in this moment in time, nothing is pushing it to the other side. So we can for sure know that this one is wrong. It's because it's on the surface, it's gonna have a normal force. So the second one is also wrong. This one would be correct if this was on the other side. So this one's wrong, and that means that D is correct. Moving on, because your force of friction is moving, making it go slower as it keeps traveling. Anyways, this one is gonna be a bit a lot, not really a lot, but anyways, we're gonna remember this as F of T of Y, F of T of Y, right? Right, wait, let me see what I did real quickly. Doesn't matter. I am just gonna write this as sine of 24 times 45. You can put that in your calculator. Cos of 24 times 45. So your free body diagram should look like 7 kg, 70 newtons. What did I say? Cos 24 or 45 was around 41.11 newtons, and then this would be around 18.303 newtons for sine of 24 times 45, and then this would be your friction, F K of F, and you still have a normal force right here, F of N. I apologize if that looks really horrible, I'm just speeding through it. What is the magnitude of the normal force acting on the carton? So I really gotta do is know that F net of Y is gonna be 0 because it's not moving up or down. So 0, and then we're gonna remember that it's gonna be F of N plus 18.303, right? It was 303, right? Yup. Minus 70. So let me actually just rewrite this here, because we know it's 0. It's gonna be, we're gonna move 70 to the other side. 70 is equal to F of N plus 18.303. Subtract 18.303 on both sides, and we're gonna get F of let me just bring the calculator here, because I'm tired of looking at my paper back and forth. Should give us around 51.7 newtons. There's your first one. What friction force acts on the cartoon? Not on the cartoon, on the carton. We know that Fk of F is equal to mu K of Fn, and they give us mu, so it's going to be 0.52. So 0.52 times Fn, and thankfully we found that out right here. It's going to be 51.7. Multiply this out in your calculator, 0.52, and you'll get around 26.88 newtons. There you go. That's your answer. What is the acceleration of the carton? We know that F net of x is going to be mass times acceleration was 7, right? Yeah, 7 times a is equal to, and now that we know, what was it? 41.11, yeah. 41.11 minus our force of friction, 26.88. We subtract that out, 41.11 minus 26.88, and we get 7 times a is equal to 14.23. Divide both sides by 7, we get a is equal to around 2.03, not newtons, meters per second squared, right? This is meters per second squared, right? I don't care. There's your answer for that one. Moving on, third page, I think. Yeah, here it's telling us what is the tension in the rope during the acceleration. So the problem here is okay, let me read it first. A 2.00 kilogram object initially at rest on the ground is accelerated vertically by a rope as shown. The object reaches a height of 3 meters in 1.50 seconds. What is the tension in the rope during the acceleration? Okay, first let me just draw a free body diagram. You can see some of my work I originally did. 2 kg. We have over here F of t, and then here F of g, which is just going to be 20 newtons. Anyways, we have to first find the acceleration. So we're going to bring out our trusty friend. First, we got to write down what it tells us. It goes to a height of 3 meters and what was it, 1.5 seconds? Yeah, 1.5 seconds. And the its initial speed vi is 0 meters per second because it's at rest. So we're going to use this equation. Change of x is equal to bi change of time plus 1/2 a of change in time change in time squared. So we're going to plug in our units. 1.5, that's the wrong one. 3 is equal to 0 times 1.5 plus 1/2 a times 1.5 squared, which is going to be 1.5 squared. 2.25. That means 3 is going to equal 1/2 a times, well, actually we can just divide 2.25 by half. So divide that by half is going to be a times 1.125. Divide 1.125 on both sides. We get a is equal to 3 over 1.125, which 3 divided by that. If you want to have an actual like decimal, it's going to be around 2.67 meters per second squared. Now that we know a, we are now able to calculate the tension. Yeah. So F net is going to equal to F of t minus F of g. So 2 times, what did I originally write? 2.67 is going to equal to F of t minus 20. So multiply that out by 2. It's going to be like around 5.33. It's going to equal to F of t minus 20. Add 20 both sides to get F of t is equal to 25.33 newtons. There you go. Moving on to the next one. A jar slides horizontally across the table. The jar is slowing down because of friction between the surface of the jar and the table. If the coefficient of kinetic friction between the jar and the table is 0.20, what is the magnitude of the jar's acceleration? So let's first draw a free body diagram. We actually, do I even need to draw a free body diagram? No. We know that mu of k is equal to 0.2, right? And we know that F of net in this case, it's going to be, because F, it's on the x and it's slowing down and there's no force pushing on it, it's just going to be F k of F. So let's write down the units. M of A is equal to mu k times m times 10, because normally force normal is going to be mass times 10, similar to weight. So we're going to divide by m on both sides. We get A is equal to mu of k times 10, which is just, since we know 0.2 is mu of k, A is equal to 2 meters per second squared. That's a horrible meters per second squared, but that's fine. Here we have another tension problem. Okay, we don't have actual numbers though, so basically what it's telling us is that this guy, right, he is a mass, and F of g is equal to mass times gravity, right? And since he's not on a surface, he's being the rope is supporting him, and they're both equal. I'm assuming both are equal. They look both equal, so they're gonna be same size, T2 and T1, right? And well, T2y and T1y, and then T2x and T1x, because it is slanted like that, like a triangle. But we know that the top, the vertical one is going to be, because of our triangle data, and this is T2. We know that this is going to be sine of theta times T2, and since both are like the same, I'm just going to say times T. Let me actually just get rid of T2 right there. So we know that f net of y is going to be equal to 2 times sine of theta times t minus m of g. And then because this f net of y is just 0, we're going to do m of g. We're going to move m of g to the other side. Is equal to 2 times sine of theta times t. We're going to divide by 2 sine of theta. 2 sine of theta. And we're going to get t is equal to mass times gravity over 2 sine of theta. There you go. That's your answer for that one. Moving on. These are the last few. I hope this video isn't too long. I'm really rushing through it because I want to. Anyways, here it tells us our acceleration. The force right here that's pushing on is going to be 15. The force that's pushing down is going to be 10. And the mass is 2.5. So I'm going to rewrite this as 2.5. And then this is going to be 15. And this is going to be 10. And then this is still going to be 25 because this is f of g. A normal force has to combat against both this force and the weight, so it's going to be 35 newtons. And then we have our Fk of f, and we want to know what is the approximation of the coefficient kinetic friction, right? So we know that f net of x is equal to 15 minus k, not minus k, minus Fk of f, and we know that the acceleration is 2, so 2.5 times 2 is going to be 5, is equal to 15 minus k minus Fk, oh my god, I'm messing up so much, minus Fk of f, and then we subtract that, it's going to be negative 10 is equal to negative Fk of f. And then now we write this down to its simpler terms. Negative 10 is equal to negative mu k of 2.5, right? Sorry, I made a mistake right here. I had no reason to add mass because Fn is mass times the other stuff. So I just need all I really care about is 35. So divide that by negative 35. Negative 35, and you're gonna get around 0.2857. So that's your coefficient. Anyways, right here, moving on, we have a rocket shot vertically upward. So let's visualize this. It's shot vertically upward. It lands on the exact same spot. We want to know, let's see, what best describes, okay, I'm not showing you which one because I have the answer actually circled on there, but we're basically just using units. So let's see, what did it say? Okay, starting speed vi, right? This is gonna be I'm pretty sure, yeah, just vi, right? Or we're gonna use this spot. Our final speed at, whoa, what in the world happened there? Our final speed at this spot is going to be 0 because velocity in the y direction, it's at that point it's switching from going up to going down, so it's going to be 0. Anyways, after this we know What do we know? Okay, we know that g is equal to g, and that there's definitely a change of x here, right? Some change of x. That's what we're trying to figure out. What best describes the change of x? So we're going to use the equation vf squared is equal to vi squared plus 2g times change of x. And in this case, it's going to be 0 bi squared plus 2g change of x. Gonna move this negative v. Sorry, this is actually negative g because the acceleration on Earth is pulling us down. So negative bi squared is going to equal to negative 2g change in x. So divide by negative 2g, you get change in x is equal to vi squared over 2g. That's your answer. It should be A. And then over here we have 14. A small rocket for gathering data has a mass of 30 kilograms and generates a 1500 newtons of thrust. If the rocket is launched straight up, what is the magnitude of the acceleration of the rocket? Anyways, okay, we have 30 kg, and then we have f of g, and then we have 1500 newtons. And since I'm gonna assume it's already launched, so no normal force, and F net of y is gonna equal 1500 newtons minus 30 times 10, 300 newtons down here, 300 newtons, right? But we're not trying to figure this out. Let me just write that down. 1200 newtons. We're trying to figure out what is our acceleration. So we're going to divide by 30, which is the mass, and our acceleration is going to be 40 meters per second squared. There we go. Easy. A 10 kilogram block is set moving with an initial speed of 6 meters per second on a rough horizontal surface. If the force of friction is 20 newtons, approximately how far does the block slide before it stops? Okay. Here we have 10 kg, and we know it has normal force and a force of gravity. So sorry, it has a force of weight. I actually think I'm writing this wrong. It's supposed to be F of W, right? Doesn't matter. Okay, yeah, I think I've been writing this wrong this entire time. But this is gonna be 100 newtons. So this also has to be 100 newtons. I don't even remember if we actually need that information. Anyways, the force of friction is going to be 20 newtons, right? And we know that the initial speed is 6, and that it goes down to 0, and we want to figure out change in x. Let me actually look at what I did here. Okay, yeah. F net of x is just going to be friction, so negative 20. And we know that our mass is 10 times a. It's equal to negative 20, divided by 10, divided by 10. Our acceleration is going to be negative 2 meters per second squared. So now we know our acceleration is negative 2 meters per second squared. And now we can plug this into an equation. Vf squared is equal to vi squared plus 2a times change in time. So 0 is going to equal to 36 plus negative 4 change in time. Change in x, change in direction, change in what I forgot. Change in x. So negative 36. 36. We're going to move to the other side as negative 36 is equal to negative 4 change in x. Divide by negative 4, divide by negative 4, you get change in x is equal to 9 meters, and that's going to be your answer. It should be D on the homework. And then here we have our last question. Finally, a 40 kilogram crate is suspended from a beam by 2 vertical ropes. What is the tension in each rope? So I'm going to say 40 kg, right? And they're being held up by 2 vertical ropes. not like slanted ropes, 2 vertical ropes. F of G should equal 400 newtons. These 2 ropes should be sorry, F of net Y. These 2 ropes should hold the exact same value of newtons as F of G, so you can really quickly figure out what it is. Since it doesn't really specify anything about these, and by painting a picture, these 2 ropes seem to have the exact same tension. All you gotta do is gonna be 2 times T minus 400, right? And since it's not moving in the Y direction, it's just gonna be 0. It's equal to 2 times T minus 400, which we just move 400 to the other side, is equal to 2 times T divided by 2. T is equal to 200 newtons, and there you go. That's the guide on how to solve every homework question on physics. I hope you guys enjoyed watching this video. Let me know in the comments if I made any mistakes saying some words, because sometimes when I'm speaking really fast, words just go past me and I don't know if I'm saying something that's wrong. Anyways, but I hope you guys enjoyed and that this further improved your understanding of physics, and I'll see you guys next time. Goodbye.